This conference will now be recorded.
Hello, everybody. Jordan Girth from the National Weather Service Office of Observations here. Thanks for joining us today. We got a great presentation about GOES 16 land surface temperatures and inland lake water temperatures from Jerry Wiedenfeld at the Weather Service Forecast Office in Milwaukee. Just a few reminders before we get started that the session is being recorded and we will have some time for Q&A, but if you do have a question that's on your mind, feel free to type it into the chat box and we'll make sure to get to it or follow up with you after the time. We are always looking for future presenters, so if you have an idea, please get in touch with us. We'd love to have you present on satellite applications. And as always, a reminder, the training team at OCLO, FDTD, and their affiliate staff are willing to help create training materials that may be unavailable related to satellites or other things. And Brian Mata is out there for information or questions regarding that. So just let us know how we can help make your life easier as a SU or forecaster. Thanks to our Tower S team, Lee Byerly, David Blutis, for their help arranging this. Also, OCLO, GOESAR, and JPSS for their support. I'll introduce Jerry now, who started working for the NWS at MDL in 2002, and then he transferred out to be the ITO at the Milwaukee Sullivan office. He's been working on multiple modeling projects, such as the original multi-member ensemble called SuperBlend, which was the precursor to the National Blend of Models, as well as another ensemble tool called ModelCertainty. So with that, Jerry, welcome. Look forward to what you got to say today.
All right, can you hear me, Jordan?
Loud and clear, loud and clear.
Awesome. Sounds great. Yeah, so as Jordan said, I tend to get myself sort of on this developmental track of things. I spent quite a bit of time working on different ensembling style of things. So this is a little bit outside of that realm, but still in the modeling world. So it's been a fun little project. I got started on it about 2 years ago. I tend to like to get looking around to see what other offices are doing, and I saw this neat little rec product from I think it was Great Falls, Montana, where they were doing a nice little organized text product for their inland lakes, and they had two big ones, and I thought it would be neat to sort of apply that on a larger scale to most of our inland lakes here in southern Wisconsin. So with that, I'll dive into this thing. So, as for background, we have a lot of lakes here in southern Wisconsin, and they really get a lot of boater traffic throughout the spring and all the way into the late fall months. In fact, recently I had an individual contact me and say, hey, we actually use that out into November, right up until the ice comes, so can you please keep it running? I was killing it in late October, and so he wants me to continue this pretty much through the month of November now. So it's been a product that a lot of people have been using, and so I've been tweaking it here ever since I started. I'm sort of the everlasting putzer when it comes to these things. So you might ask yourself, why am I dealing with trying to create a text product for all of these inland lakes when a lot of this information may already be available on the point and click, like temperature, wind, precipitation, sky, and all that. And while it is available, but it's not necessarily nicely organized, and the point and click is missing a couple of the most useful elements from this, and that's wave heights and water temperature. And so that's sort of why I thought this would be a good product. We have a lot of boater traffic from all over the place, so including like Illinois and Iowa, and people are coming from a lot of different places. So to get this organized can really help. For this particular product, yes, we have more than 37 inland lakes, but I wanted to keep it to lakes that were around 5 kilometers or larger, and I wanted to keep it to the lakes that were mainly that had high population densities as well around them, so a decent amount of people actually living on the lake and have lake frontage. So let's dive into those wave heights just for a little bit. I know this might be a little bit out of the realm of satellite world, but it's still something I found quite interesting, and it was fun to work on. So we ran the Glaral wave model for quite a few years here. Most of the Great Lakes sites were running it. It's just a really basic model. It uses, I think it's for shallow lakes, and it's a Fortran based model, and I'm running it actually on a completely separate domain within AWIP. So we have two domains in our AWIPs. We have our standard MKX domain, which is basically like the image you're seeing here. It's the whole thing. And I'm running it on a little bit smaller domain that covers mostly a portion of our MKX domain down here in southeastern Wisconsin. It's at 500 meters, so it's a pretty high resolution domain. For wave heights, our first guess is the previous forecast, and this is a little bit of the trouble once I turn this thing back on because I don't have a really good first guess, especially for the wave heights. So I have to dummy some data based on the winds and wind directions that we have. Usually it's just a constant field of a certain wave height, but even with that, it can cause some sort of erratic data on that first run. So it usually takes me about 3 to 4 runs, maybe up to 5 to get things sort of smoothed out, and so it's running good. So at the beginning of the year, I usually turn it on, and I don't actually post any data for about a week, and then I'll actually start posting the data. The winds, they're imported from the NDFD or the official database. I'm actually just grabbing them straight from within AWIPS itself, and they're at 2.5 kilometers. And so one of the big problems here, and this is an image of the gridded product of the waves. One of the big problems is I don't have any ground truth. There's no buoys that actually have any wave heights. I've been trying to work with SSCC to see if they can have their buoy that's on Lake Mendota provide us wave heights. So hopefully at some point that might happen. But right now we're just relying on subjective verification. It's, I myself, I like to go boating. So we usually go boating on Lake Koshkonong, which is sort of right around Dane County. It's one of the larger lakes in southern Wisconsin. And so usually when I go out, I'll just sort of take an idea of what it's saying and then look to see what the wave heights are about. So that's the only thing we really got for verification is just what people are telling us. So now water temperature. Water temperature proved to be a little bit more difficult of an animal to get. And you might ask why I spend so much time on water temperature. Well, we live in, southern Wisconsin, sort of that northern climate. So, we can get those 80-degree days in early March, mid-March, and those lakes can be pretty cold still. Some of them would have just opened up and not been full of ice. So, to have that water temperature forecast, especially in the early spring, is very important. Another issue is fishermen. Fishing is really big here, and what I found just from feedback is that fishing is, highly dependent on what water temperature is. And I think the largest fish I ever caught was maybe the size of my hand, so I'm obviously not knowing any of that kind of stuff, but it's something that I've been told is quite important. And all these lakes, they're sort of different size, different depth. Lake Koshkonong is about 6 feet deep, but it's one of our largest lakes in size. Lake Mendota, however, which is right in Madison, is pretty deep. You can get 30, 40 feet deep, and it's a little bit smaller than lakes, so they're gonna, temperatures are gonna vary quite a bit between lakes. And yet again, we have that one buoy that we can get information from. That's in Lake Mendota, and it does give us, that's what you're seeing here, some good lake temp or water temperatures, it actually goes more than just the surface. It goes down, I think, 20 meters or something like that. Or not 20 meters, like 2 or 3 meters. So it gives us quite a bit of information there. So with only having that one buoy point, I ran into some problems. What do I do to get that lake water temperature? Obviously, one solution could be to just set all of the lakes to Lake Mendota buoy temp, but I don't think we're doing any justice to the size of the lakes. And really, at that point, anybody could just go look at that temperature and get their idea. So I dismissed that pretty quick. Another I thought I had was the GO sea surface temperature, and I'll dig into some of the problems with that. Then we have the GO's land surface temperature, which again, there's some issues that arise, and I'll dig into that a little bit here in a bit. And then, obviously we have just model temperatures, HRRR, RTMA, and we could probably use them, but again, they're surface temperatures, so they're not necessarily telling us what the water temperature is. Or could I use some kind of combination? And, I'll dig into a little bit about what I did there. So as far as the GO sea surface temperature, as you can see here, this is Wisconsin, and you can see Lake Michigan and a little bit of Lake Superior. But if you look back, here's my lakes. There are no lakes in the sea surface temperature for GOs. So that's not going to really help my inland lakes that I want. So I had to sort of throw that one away. And another little issue is, and I think this is also an issue with the land surface temperature, is they're dependent on the clear sky. So if you have sky cover, that can certainly get in the way of actually seeing down to that sea surface temperature. So here's the GO's land surface temperature, just an example of it. And again, you can see the clear sky issues over there in the Minnesota, northern Wisconsin area. They're pretty cloudy, so they're not obviously able to see down to the land. Right there, I have it highlighted. That's right where we had some lakes. So in that situation, it would come up as missing. So I had some solutions around that, and I'll get into that. As far as GO's land surface temperature versus the sea surface temperature, this was something that sort of stuck out at me. This is taken at the same exact time, and you can see there's about a 6-degree temperature difference between what the sea surface temperature is and what the land surface temperature is over Lake Michigan. So and that sort of highlights what the problem here is. It's a land surface temperature, not a sea surface temperature. So we're not going to get the same estimated temperatures here. So there's going to be a little bit of a bias if I decided to go down this route of using the land surface temperature. Another problem I ran into, in this image, you can see some really cold temperatures over there. This is actually, I zoomed out quite a bit. I think this is over in North Dakota to get to this area. But underneath it is the RTMA, and that's hovering at around 52 degrees. But in that area, you have some cirrus, I think, pollution, where it's interpreting the cirrus as actual land, and so then it comes up with temperature in the 30s. I did this back in the spring, so that's why the temperatures are a little bit cooler. So that's a problem that I had to deal with, and I'll talk about how I dealt with that once I get to some of my other slides. Another potential was this HRRR surface temperature. So here with the HRRR, I'm looping it through sort of the start of the day at around 12Z and going straight into the afternoon. I've highlighted some of the lakes, and you can see they're varying quite a bit. Lake being a body of water, they do warm because they're smaller. It's not like the ocean where it's going to warm, over a week time frame. So they will change by a couple days or a couple of degrees throughout the day. But here the HRRR is showing, I think 5, 6, 7 degree changes for some of these. And the other issue is it is a surface T. So I had to deal with this a little bit. I did want to try to utilize the data for now. there is a caveat here. Version 4 of the HRRR is actually going to mitigate this, so you won't see these lakes pop out as much. And I agree that the surface temperature was probably a little bit too different from what the surface temperature around the surrounding points. And another issue is, if you really look in there towards the center of Dane County, if you're familiar with Wisconsin, that's sort of where Madison is, you can see that the Lake Mendota there isn't actually directly over what the shapefile is saying the lake should be. This could be maybe due to wind direction, or just the shapefiles aren't lining up exactly the same as what were used when the HRRR did their modeling. So, and not all the lakes are even represented. You can see some of the lakes there, and there is no difference. So this is, I had to use this one with a little bit of care, I'll say. So let's dig into what exactly I did. So the water temperature computation that I chose, I decided that I could only actually do this in the morning because most of the year we're going to be warming up, and the coolest the lake's going to be is going to be in the morning. I didn't want to get a lot of that warmer temperatures that we were seeing from the HRRR in the afternoon, as well as the land surface temperature from GOES, that was also showing a big bias in the temperatures in the afternoon. So I decided I'd only fetch the midpoint of each lake once a day at about 12Z in the morning. And I actually fetched the HRRR, the GOES land surface temperature, as well as the previous lake water temperature that I computed from the previous day. For Lake Mendota itself, I actually am just grabbing that Lake Mendota buoy water temperature, and I set that point straight to that. I don't mess with anything else because I take that as ground truth. For the rest of the lakes, however, I'm using an average of the previously computed Lake T, the HRRR surface T, as well as the GOES land surface T. Now for GOES, due to the cloud issue, I had to sort of look back for multiple cycles of the GOES until I actually found data. I think I looked back 8 different versions of it. And if I didn't find any data in that amount of time, so if we've been cloudy for, a while, then I just eliminate that from the average, and I'll just use the previously computed Lake T actually on that day. And the same can be said for the HRRR. If I, for whatever reason, if that's missing, it just won't be included in the average. So I also had to do some extra checks there for that cirrus pollution issue. Once during the spring is really where this check takes into account, because I'm expecting the water temperatures to either warm or stay about where they're at as we get to the longer days. So basically I look at the average of what's been computed, and if that average is way cooler because of some problem with what's been fetched from the GOES land surface temperature, I'll throw that data out and I'll just use the previous lake water temperature for that day. This gets a little bit tricky in the fall because in the fall, obviously, the lakes are going to start cooling down. So I have to do some extra checks in there with standard deviations and that kind of thing in the fall. So that's that one I'm going to have to revisit this fall a little bit more because I'm not certain it was doing what I was hoping it was doing this past fall. So once I get to that midpoint, so that was all just about actually fetching the data. Once I get to the midpoint, I run a SERP analysis that was created by Boise, Tim Barker over there. He created that for GFE purposes, and it creates a pretty decent analysis if you have enough points. And actually, it will, create the analysis over the whole grid. And then I have a mask that I created to mask out where all the lakes actually are that I was interested in. So I do get a 500 meter resolution of gridded lake temperature on a grid that we then can use. So I'm going to wrap this thing up now. The GOES land surface temperature, it does provide an answer. for lake water temperature. I think it has some issues. I think it might have a cold bias with it, or a warm bias, not a cold bias. It might be a cold bias in the wintertime or the fall time. But that cirrus, that's another issue. It would be nice if we didn't have to deal with cirrus pollution. But I can get around that here and there. The GOES sea surface temperature, obviously, I think this would provide me a better answer. But right now that is not available over inland lakes. So if that could happen, that would be fantastic. Using the HRRR and other models, I think it's a good sort of first guess, especially if you only use it in the morning. But I'm not, I myself, I think I'm just using that as more of a stability factor, and also to help with the cirrus stuff. And even if we did get sea surface temperature for GOES, I think that may even help models like the HRRR for those little lakes that we have here. It may be a better way for them to, get that surface temperature over the lake, rather than trying to do some of the smoothing that they're doing now. Another huge benefit would be if I actually had more lake observations. I think that would help me, derive the best technique and to verify things a little bit more, and I get some more ground truth. Obviously, that's largely out of my hands and out of the National Weather Service hands. But if we could get some more buoys, that would be awesome. So with that, I think I'll wrap it up, and I'll take any questions that anybody may want to throw at me.
All right, thank you so much, Jerry. That was a great presentation. So at this time, we will start the Q&A session here. And again, with the large audience, we will encourage you to submit your questions to the chat room. If you would like to ask a question verbally, you could also indicate that, and we will make sure you are unmuted. And I did just share in the chat a link to a short feedback survey. We certainly encourage you to complete and submit that if you'd like to. And so the first question we have here from Scott Lindstrom, he asked, he says, JPSS has high spatial resolution, less than half a kilometer lake surface temperatures derived from direct broadcast antenna data in Madison. And he asked if this data could be used for this application.
Yeah, most certainly. I've been looking at trying to use VIIRS, but going down that road, that'd be awesome, Scott. So if you can help me get to that data, I would love to try it. I'm wide open. I love putzing with this stuff. So any way I can use things would be great.
Okay. We have another question here from Ethan Burwell. He said, I know you're not forecasting for Lake Mendota because of the buoy, but he was curious if you attempted to compare the process with the buoy temperature on Lake Mendota.
Yeah, I did. And I think that's where I've sort of determined that I have a little bit of a bias. I think it's a warm bias because of that land surface temperature in the HRRR. So that's why I decided with the lake water temperature to just stick where I knew I had data, that buoy data, I would stick with it because I think that's providing me a little bit better answer. Now, that data, because I'm doing that serpentine analysis from Lake Mendota, it does actually have an impact on some of those closer lakes like Lake Monona. There's a chunk of like 5 lakes around Madison that Lake Mendota can have some influence that buoy does.
We had another question here, probably kind of goes along with Scott's question from Bill Schoberg. He said, did you look at any of the polar orbiting land surface temperature, sea surface temperature data?
I have not yet. I mean, I tried to use, I don't think this is polar orbiting, I think it's derived product. But another one I did try to use was MODIS. But unfortunately with MODIS, when I try to grab it through the DAF, it's a data access framework, and AWIPS, I couldn't get it into the right unit computation. And some of that stuff, now with the polar orbiters, I guess I haven't looked at that as much. I looked to see if I could find any land surface temperatures that I could, so maybe I just wasn't looking in the right spot. But certainly if you want to point me in any directions, I like I said before, I love digging into this stuff. So if I can find a good answer, I will use it.
And we had another, it looks like a kind of a comment here from Yunye Yu. He's the LST lead at STAR, and he said he says considering that GOES LST includes inland water temperature as well, he believes that you would need a GOES SST additionally. I guess, did you want to make a comment on that, or did you have any?
I'm looking at that chat right now.
Okay.
I don't believe you need GOES. Yeah, well, I mean, what I found was, that land surface temperature. Yes, while it's available, it just like when I compare it directly to that sea surface temperature, and then compare it to what the buoys are off of in Lake Michigan, I just found that land surface temperature, while it provides me an answer, it is not. It does have a bias with it because it's, I think it's trying to do land, not necessarily water. So I hope that helps or answers that comment.
Okay. It looks like we have one final question from Todd Boise. He asks, is there any of what you've done with GLERL on inland lakes and using GOES for lake temps on the software collaboration portal, or are there any plans for this? And is there documentation for WFO setting up using the GLERL for inland lake wave heights?
So as far as the GLERL goes, I know Green Bay is using it for Lake Winnebago. You guys may have saw that I chopped Lake Winnebago in half because we sort of share that lake. So they are using it, and I think that actually goes out to the NDFD. And then Great Falls, I believe, was using GLERL, and I think they actually got their original setup from Green Bay. So no, it's not on the software collaboration portal. It does require a little bit of massaging to get it to run, and I'm happy to try to get it there. I think Nick Langalebe was the person that he was the ITO over at Great Falls, but now he's the SU at Marquette. So he and I sort of did a lot of that wave work together. I can talk with him to see, if he feels comfortable working with me to get that onto the software collaboration portal. As far as water temperature stuff, I mean, yeah, I think I would put both there. Now there's lots of hard coding, so right now it's not pretty, but I can make it better. I've done that a number of times. So if you're interested, Todd, just contact me and I can try to point you in the right direction.
Okay, yeah, I'll do that. Thanks.
Mm-hmm.
Okay, and with that, Jordan, I will turn it back over to you.
Okay, thank you, Jerry, so much for presenting today. Always like hearing about southern Wisconsin weather and lake issues. I grew up in Kenosha, as some people on this call may know. In any case, thank you so much. For those of you on the call, hope you're going to be able to join us next week on Thursday, July 16th. William Churchill from the Weather Forecast Office in Key West is going to present on cloud line formation in the Florida Keys and how GOES imagery can be combined with radar data to assist in warning operations. So looking forward to hearing about that more subtropical perspective. I believe that David will be sending out a survey if anybody has any comments about how we can improve this. So please let us know if there's any topics that you're interested in, or we can tailor this better and make good use of your time. With that, hope everybody's staying well, has a good summer. Hope to see you next week. Thanks to our Tower S team and thanks to Jerry. Stay well. Join us on another Satellite Book Club soon. Bye, everybody.